By the early 1970s, two-way communications between continents by satellites was becoming a rapidly growing business. But because of the limitations of the technology at that time on the power that such satellites could transmit, the entry points to the system were restricted to very large Earth stations. These stations, which had antennae typically of 30 meters diameter, required large investments in equipment and manpower. Due to advances being made in satellite technology with higher power available from the same mass in orbit, the possibility of smaller and more numerous Earth stations on the ground started to become apparent. Satellite communication could then be considered to be economically viable over shorter distances, such as in Europe. At this time, the European Space Agency, then called the European Space Research Organization, started work on the first multinational telecommunications satellite in Europe, the Orbital Test Satellite, or OTS. This was designed at ESA's European Space Research and Technology Center, ESTEC, in the Netherlands, and built by a consortium of European companies led by British Aerospace. The first launch of OTS by an American launcher in 1977 resulted in failure. A second OTS was successfully launched from Cape Canaveral by an American Thor Delta launcher in May 1978. OTS was designed to test in space the technology needed for later operational satellites and to act as the catalyst for development of satellite communication systems and markets in Europe. Such an important satellite required extensive deployment of hardware and facilities on the ground and experiments and demonstrations which would form the basis for future communication systems. The first OTS Earth station was built by the agency in collaboration with Telespazio at Fucino in Italy. The station, called SCTS, for Satellite Control and Test Station, was used to receive telemetry and transmit telecommands for the control of the satellite in orbit and also as a communications test facility. OTS proved the European satellite technology for later operational satellites. At the same time, it provided satellite capacity so that a wide range of new communications hardware and techniques could be developed and tested on the ground. High-capacity telephony systems, digital data communications between small Earth stations, television distribution techniques were all developed and market-tested using OTS. Even at this time, the agency was preparing to launch the successors to the OTS satellite. 5 ECS European Communication Satellites and 3 maritime satellites, or MAREX, were under construction. At the same time, a new large in-orbit testing facility, TMS-1, Test and Monitoring Station number 1, was being constructed at Redeux in Belgium to measure the performance of ECS satellites as they were launched. This was to be the first step in establishing an in-orbit testing facility covering the requirements of the ECS satellites now being launched on a regular basis for commercial use. For the ECS satellites, the exploitation of the payload capacity is the responsibility of Eutelsat, representing the PTT administrations in Europe. The agency, however, retains orbital control of the satellites and thoroughly tests each prior to handing it over to Eutelsat. 4 ECS satellites are now in orbit and provide communications, telephony and television from and to all parts of Europe. as well as television distribution from various broadcasting companies going to tens of millions of homes. In the maritime field, satellites MAREX-A and B, also derivatives of the OTS design, have been leased by ESA to Inmarsat, the International Maritime Satellite Organization. They are used on an operational basis over the Pacific and Atlantic Oceans and provide one of the most efficient communication means available for ships on high seas. Using a little of the MAREX satellite capacity, the agency has been able to develop the technology for land mobile services, which will find extensive application in future SATCOM systems. This is the PRODAT system, which shows great promise in providing communications to people on the move. With the exploitation of ECS and MAREX satellites in the hands of Eutelsat and Inmarsat, and their control now a routine function of ESOC, the agency has turned its attention to the next generation of larger and more powerful satellites. Like its predecessor OTS, the new Olympus satellite offers the potential to develop new services ahead of commercial exploitations. Olympus, with its powerful direct broadcast beams, offers the possibility to broadcast direct to millions of home antennae over wide coverage areas. It also provides capacity for expansion and exploitation of satellite business services and has capacity at the newer, higher frequency band allocations of 20 to 30 gigahertz. Olympus 1 was launched by Ariane 3 in July 1989. After successful in-orbit testing by ESA's now well-established test facilities, the satellite was declared ready for use. The Operations Control Center for Olympus is in Fucino, Italy, scene of the earlier OTS measurements and perpetuating a long-standing cooperation between the agency and Telespazio. Olympus contains a mixture of trial payloads for future missions. As with OTS a decade earlier, the agency has initiated a utilization program for Olympus to pave the way for future commercial systems. In the field of broadcasting, both the BBC and the RAI, the Italian broadcasting company, are broadcasting television through Olympus, direct to homes across Europe and building up audiences for future satellite services. These transmissions can be received on very small domestic installations. In the field of specialized services, Olympus is providing capacity to a wide range of users who are developing and promoting new business and domestic voice, facsimile, and data services in Europe. In the newly allocated frequency bands of 20 to 30 gigahertz, a large potential exists for satellite communications. Olympus capacity is being used in Europe and in Canada to develop new, very small Earth station systems, which will permit users direct access to each other via satellite with a degree of flexibility never before possible. Such systems can accommodate vast amounts of voice, data, and video traffic.
One has to speak up a little bit when we're speaking.
The flexibility and potential of modern satellites is now frequently demonstrated with transatlantic television exchanges using the steerable spot beams of Olympus to bring television events over the Atlantic for rebroadcast in Europe, again by Olympus.
Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
A highly versatile Earth segment capability has been developed to exploit the high power and beam steering capability of Olympus. The Earth stations are mostly transportable, so they can be used in a number of countries according to need. As an example, 2 satellite multi-services stations with 3.5-meter diameter antennae have been constructed by British Aerospace in the United Kingdom. These are being used as hub stations for tele-education experiments. TDS-5 is a 4-meter diameter television uplink station constructed by Selenia Spazio, now being used in London to send television pictures to the satellite for broadcasting. Many 20 to 30 gigahertz transportable stations have been developed by ESA and the user organizations to exploit the satellite capacity. These will be used to expand and encourage the development of new services in Europe and in Canada. Looking to the future, the agency is now beginning development of 2 new satellites. Artemis is a satellite to test the technology which will be used in future operational systems for data relay and land mobile applications. Artemis will develop the techniques needed to bring signals from space to ground in support of the European space program in the next decades. In this respect, it will use not only conventional microwave techniques, but also optical techniques for the space-to-space connections where the Earth's atmosphere is not present to attenuate the signals. Artemis will also carry an experimental land mobile payload which will support the 2nd generation of vehicle communication systems in the future. Data relay satellites. These will provide the main highway for space-to-Earth communications in the next era of space exploration. 2 such satellites will enable signals from future manned and automatic space vehicles to be sent to and from the Earth. In addition to these, ESA is developing the payload for a future European mobile satellite, EMS. This satellite will be specifically aimed at operational services to commercial and private vehicles. The changes taking place in Eastern Europe make such a system even more important. It will provide the potential to extend mobile communications over a whole continent. The European Space Agency continues to work in the forefront of technical development, both in space and on the ground, to provide the basis for the communication systems of tomorrow.